I'm Eric Larson, and I'm the Water Supply Specialist for the Montana NRCS Snow Survey Program. It's important to fill out the whole snow note while on site. That way you can take a picture of it, save it in your pocket in case you lose the note way back. Fill out the whole note, including the averages, all the point numbers. Fill out the number of tube sections used. Was a driving wrench used, yes or no? Number of sheets. If you had a lot of resamples to maintain your 5% density spread, then you might have more than one sheet. Who it was completed by, who it was checked by on site. Then flip the note over and fill out any sampling conditions on the back, weather at the time of sampling, snow conditions at the snow course, general conditions, and if you're at a snow tell site, which is adjacent to the snow course, then there is a spot for precipitation data also. Good note taking is very important. If we ever need to troubleshoot maybe why one point is significantly different than another when we're looking at the note back in the office, it's always good to have notes and remarks, clean, legible notes that we can read your handwriting so we can determine why there might have been an issue with a certain sample number. Things to note include whether you had an earth plug or any evidence of grass or pine needles. For example, if I ever do have pine needles, I'll just write an EV in the remarks to say there was evidence of those pine needles or whatever it was. If you have an earth plug, you can just note EP for earth plug. In terms of the math on a snow note, so snow depth, length of core, weight of tube, weight of empty tube, water content, density %. In terms of the math on the snow note, the water content is equal to the weight of the tube and core minus the weight of the empty tube. Now the empty tube is not 0, it's whatever the empty tube is with no snow in it. On the scale, remember we're using 3 tubes, so we extend that scale into a certain range that's not like right at 1 or 2, so extra weight of 3 tubes helps with that. The length of core is just a quality control measure to verify that you didn't lose any snow or that you got a sufficient amount of snow in when you were plunging the tubes into the snowpack. The density % is the water content divided by the depth of snow. It's important to calculate your density as you're going along to each sample point throughout the snow course. You shouldn't have more than a 5% density spread. Depth can vary, but generally density doesn't vary more than 5% across the snow course. One example is a 25% density to a 30% density. That's what I say when I mean 5% spread. If you do have any outliers outside of 5%, you need to resample those up to 3 times. Once you've resampled any outliers 3 times, then it is okay to have greater than a 5% density spread. In terms of rounding, depth of snow gets recorded to the nearest 1/2 inch. Length of core gets recorded to the 1/2 inch. The weight of tube and core, if you're using a 12.5 foot scale, gets rounded to the 1/2 inch. And same with the weight of the empty tube. If you're using a 20-foot scale, then the weight of the tube and core and the weight of the empty tube get rounded to the full whole number. Density % gets rounded to the whole number.
In this example note, you can see the rounding. So for depth of snow, it's rounded to 39.5, so to the 1/2 inch there. Same with the length of core. Weight of tube and core is also to the 1/2 inch. And then weight of empty tube for the 12.5 scale, 1/2 inch. Water content, 1/2 inch. And then the density % is to the whole number. You can also see that we had to resample 0.6 a couple times. That was just because of our density spread. So our initial density on our first sample is 29%. And then on the second time, 32. So those were the outliers, and they were outside of that 5% density range. So we resampled and got 38, which aligned with the rest of the points. So then you just cross out those 2 outliers, and they are not included in your final calculations. For the final numbers, you just sum all 10 points up and then divide by 10. to get that average, both for the depth of snow and also for the water content in inches. And then for the final density, that is just the final average number, so 14 in this case, divided by 38 to get the final density percent. You don't have to sum up all the densities for each sample point. Please remember, if there's no snow at the site, we still need an official snow note for record. So in this case, I'm just showing an example. What you do, you just write on the note, no snow, or no snow at site, and then continue to submit the note to us just so we can file it in our historic records.